How's it going, everybody? Today we have an amazing problem for you guys, right? She's a very good problem. So let's see what it's all about real quick, right? So it says given a non-negative integer x, right? Return the square root of x rounded down to the nearest integer, right? So the return integer should be a non-negative as well, right? You must not use any built-in exponent function or operator, right? So interesting. So they want us to, find the square root of the number, right? But the number has to be uh what's given to us, right? We need to make sure that we round it down, right? So let's say if we don't get a even round number, right? So we need to kind of, remove the decimal part and return that, right? So that's kind of what they're saying, guys, right? So that's what we need to make sure that we do. So for the example, right, we find the square root of 4 is 2, right? Square root of 8 is 2 point something, but we remove the decimal part. We return this as the result, right? So very interesting. Okay, so um, how can we go ahead and solve this problem, right? We can't use any function, right? We're gonna have to do it ourselves, right? So how can we do it, right? So let's kind of think of brute force, right? Let's kind of get the brain juices flowing, things like that, right? That's always good to start with brute force and then work our way up to the optimal solution, right? So the brute force, right, would be, guys, right, for this example, I could see, since we could try all the different numbers, right? We could try all the numbers from 1 to 4 and check if that number squared, right, when you multiply the number with itself, right, equals to the value, right, that we're looking for, right? So but this one would be makes sense, right? But for this one, we need to worry about the case where because we don't there's not like an integer that's easy to find for 8, right? So how do we take care of that case? Maybe what we could do is to check all the numbers, right? And as soon as we get a number that goes beyond 8, when a number once we square it, it goes beyond 8, right? We get the previous number that we saw that was less than, that was less than, right, or equal to 8, right? We save that number, right, and then we return that number, right? So this example, right, we do 1 squared equals 1, right? 2 squared equals 4. 3 squared equals 9, right? So we get to 9, we would stop, right? And we said which was the previous value that we saw that was less than 8. We return 8, right? Because we're doing that because we're rounding down, guys, right? This is why we're doing that, right? So yeah, so this approach would not be too good. It would be kind of a of n, right? Because we're doing a linear scan, right? Which is not too efficient, right? But we could do it a little bit better, right? We can kind of see that we have some kind of a sorted sequence, right? Like the range of numbers that we have, right? From 1 to x, right? And we're trying all the different numbers, right? So instead of doing that in a naive fashion, right? We could do it a little bit better by applying a binary search over the range, right? Because the range is kind of sorted, right? And right. So because of that, right, we have a sorted sequence. We could apply a binary search over that range, right? We know all lower bound, we know upper bound, which is easy to find in this example, right? And apply binary search, find that number, right, that we're looking for, right? So, and what's the number that we're looking for? You might be asking, right? So this is very interesting, right? Because sometimes you might not get a proper integer, right, for a particular number, right? How do we only get the rounded down, right? Since we want to round it down, we're rounding down, right? We need to kind of think it through a little bit, right? So we see that for a number, right, if it's 2 point something, we need to find out, we remove the decimal part. So we see that what we're gonna have to do, right, is to find, right, the number. So for this problem, right, can be translated into find the highest number, right, that is less than or equal to uh a number when once you square it, right, is less than or equal to the target, right, which is 4, right? So we want to find which square the number, right? If that number is less than or equal to 4, then it's a candidate, right? But we want the highest one, right? So that's kind of what would be interesting part, right? So we apply binary search to find the exact thing. We did a problem similar to that in the past where we had to find some kind of highest number or lowest number greater than a particular element, right? So something's gonna pop out. You probably see that, right? So this is exactly what we're gonna do, guys. We're gonna find the highest number that is less than or equal to the 4, right? When that number is squared, right? When once you multiply that number, okay? So that's exactly what we're going to do, right? So for this example, right? Just do a quick example real quick. Then we got time. So 1, 2, 3, 4, 5. So let's say we got 4, right? We would apply binary search over that range, right? So I'm gonna optimize it even more, guys, right? So those are some rules that we went over last time and this other problem that we did, right? So we know that the square root of any number less than 2, right, 0 and 1, right? That number is the square root of itself, right? So that's why for the edge case where we get 0, 1, right, we return that number itself as the square root of that number, right? So it's an easy case, right? Because the square root of 1 is 1, right? So we know that, right? And so now for the cases when the numbers 2 or greater, right? There's another set of rules, right, that applies as well, right? So which is gonna be interesting, right? So we know, so there's another rule there, which is that the square root of a number, right? The square root of a number, right, is not going to be greater than that number divided by 2, right? So if you kind of think about it, like, for 9, for example, right, the square root of 9 is 3, right? But 9 divided by 2 is 4.5, which means that we see that the square root is less than the half of that number, right? Of the original number, right? So it is because of that rule, guys, that we can even cut down on search space, right? To be upper bound could be from num divided by 2, right? This rule applies to all the different numbers you could think of, right? That's greater than equal to 2, right? So a very, very good thing that you need to make sure you guys understand, right? So yeah, like I was saying, guys, right? So we're gonna be applying binary search, right? So now let's say we remove this one, right? And our search space would be 9 divided by 2 would be 4 divided by 2. So our search space would be only this one, right? And that's why we could easily return this one, right? But let's say we had that case where we just do 8, right? So 8 divided by 2 is 4, right? So our search space would be from 2 to 4. We would apply binary, so we check 3 squared equals 8. No, it doesn't, right? So we can, no, now it doesn't, right? So we decide to go left or right. So it's 3 squared is greater than 8, right? So we could remove everything on the right side, right? So let's focus on our space here, right? So we check, is uh 2 squared greater, right? No, it's not, right? So we would update the left pointer to go to the right, right? And they will cross over. So this is where the case it would end, right? And the right pointer will be pointing at 2, right? Because we're taking the floor, right? This is where we're going to be returning the right pointer as the result, right? So hopefully it made sense to you guys, right? So let's kind of quickly go ahead and uh, go into the code and solve it, right? So what we're gonna do, guys, is to have to set our boundary, right? And we said our boundary is going to be from 2, right? So before we even get into that, let's quickly do this check for numbers less than 2. So if x is less than 2, we can return that number. And yeah, so the left boundary is 2, right? And the right boundary, what is it going to be, guys? We said the upper bound is going to be num divided by 2 because that's the space that we need to worry about. Anything over that is not going to be useful at all, right? So don't even worry about that space at all. Okay, so we're going to have a while loop. This is our standard binary search algorithm, right? We're going to calculate our midpoint as well. Okay, we'll make sure to use long, right? Because the numbers can get very big. Okay. And what's next for us, right? We're gonna do a check let's also get our number squared, right? So a number squared is going to be the mid times mid, right? See how we're going to calculate that, right? So we check if that number squared, right? Does it equal to x? If it does actually equal to x, then we return that element, right? But before returning it, we cast it into an integer, okay? So let's do the case where it's not a, it doesn't equal to the number that we're doing, right? We could do our thing right there, okay? We're gonna decide to either go left or go to the right, okay? So we do num squared. It's less than x, and we know we go to the right. We need a bigger number. If the other way around, we go to the left, right? And when we go, we make sure that we return the right, right? But before we turn the right, make sure we can set it into an integer as well, right? So to just a quick recap, we said all numbers less than 2, the square root of that number is itself, right? And we set our boundary to be start from 2 to num divided by 2 because of the thing that I told you guys, right? So the properties you guys should know, right? And then we do a binary search to find that number, right? So let's press run code, see if we pass the small test case. Put x, it should be x. Press run again. Looks good. Let's press submit. Awesome, guys. We passed all the test cases, guys. So I want to thank you guys for watching the video. If you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.